Good afternoon and welcome to my Workforce Ed 105 video assignment for lesson number 8. My name is Lucas Harden and I'm at the Alberta Carpenters Training Center in Calgary, Alberta, Canada today, where it is a very nice 16 degrees out. I checked the weather actually for Penn State University and found out that it's considerably warmer. It's 45 degrees there. And that's actually awesome. So you guys are having some amazing balmy weather, and we're still just trying to catch up. I was wondering how that could be though, and I came up with an idea that perhaps it's, the distance of Canada and the US from the sun. Canada is 150 million kilometers from the sun, and the United States is 93 million miles. That's almost 60 million difference. Well, we know that that's not quite true, and that doesn't make much sense because we're all on planet Earth and we're all the same distance from the sun. So what is up with that? Why is there such a big temperature change, and why are we so much further away from the sun than the United States? Well, it all comes down to the scale of measurement that we use. And as you can see from that example, it's very confusing and can be when you're jumping back and forth from different scales of measurement. So today I want to talk to you about the metric system. And the metric system is a standardized unit of measurement. It's used in chemistry, physics, math, construction. It was developed in the 17th century in France out of the necessity for that very purpose, to standardize measurements from all over the world. Whether you were trading grains of rice, okay, it was a gram is a gram is a gram, or if you were traveling, you were always traveling the same distance and it doesn't matter the value. So the metric system was able to align around the world, for the most part, units of measurement. And it's actually a very simple method, unit of measurement to basically measure anything you need: weight, mass, distance, things like that. The way it works is there's a base unit, and then there's prefixes, okay? Different prefixes are larger than the base unit, and different prefixes are smaller than the base unit. But it's all a multiple of 10, okay, of the base unit. Now I want to read something here of why this is actually very important. This comes from the National Council of Teachers of Mathematics, and they've taken the position that students need to develop an understanding of metric units and their relationships, as well as fluency in applying the metric system to real-world situations. Because some non-metric units of measure are common in particular contexts, students need to develop familiarity with multiple systems of measure, including metric and customary systems and their relationships. That's really well said. What it means, it's important to be able to use both systems well and to be able to use them interchangeably. Okay, why this is important for construction is exactly what they said. Sometimes we're cutting 2x4s and we need to cut them into 400 millimeters. Okay, we're using an imperial system for the 2x4, 1.5 inch by 3.5 inch, and we're cutting it in a metric system measurement of 400 millimeters. Doesn't make much sense now, but when I get to the demonstration, you'll see that we can do this, okay? So, what is a base unit? Well, I've got up on the board here a meter, okay? We all know a meter, roughly this long, give or take, okay? That's the base unit, that's 1. All right, I've also got some of the prefixes here. I've got kilo above, I've got centi, and I've got milli. Okay, there are others, they go all the way up. Actually, for instance, on your phones or your computers at home, gigabyte, terabytes, megabytes, kilobytes, they all follow this. In fact, kilo is a kilobyte. Then you'd have megabyte, then you'd have gigabyte, then you'd have terabytes. And they're all in the order of 1,000 as you get higher. Okay? So even data and storage on your phones is using the metric system. So we want to use these prefixes in our measurements. These are the most common. Like I said, there's several. Okay? But we're going to use these prefixes in our example. Okay? And one question I want to ask you though, just to see if we understand exactly the direction that these are running. Okay, you can see here as well, I've got exactly what 100 centimeters is equal to 1 meter, 1,000 millimeters is here to 1 meter, 1,000 meters equals 1 kilometer. So based off that, a couple questions for you. One, what would you use to measure your drive to school? What was that? Kilometers. Yes, absolutely. Jesse, you would use meters because you live around the corner, but you're absolutely right. But, thank you, Michael, kilometers is generally what we'll use because we're driving longer distances, we'll use kilometers. Okay, what about if we're measuring the tabletop? Okay, this tabletop, roughly this long, what would we use? Meter, maybe? What if it's under a meter? Right, good job, Kevin. Can use centimeters. What if I was to measure the precise dimensions of this 2x4? Say just the width. Excellent. Karen, good job. Millimeters. So you see how we can use this system up and down to measure anything we need. Now, I could measure this in centimeters. I would get 8.9 centimeters. I've measured it in millimeters, that's 89 millimeters. You can see 89 millimeters, if I divide that by 10, I would get 8.9 centimeters. And exactly here, you can see 100 centimeters is equal to a meter, and 1,000 millimeters is equal to a meter. So there's that relationship of multiples of 10, where we can go within the metric system of measurement here for length or distance, and we can easily convert up and down within the metric system. So, with that being said, let's use the metric system and actually apply it. So we're going to measure the length of this 2x4. Now, we've required all of you to come to class with a dual scale tape. That is one with the imperial US customary units of feet and inches on the top of the tape. And we've got the metric system down here on the bottom of the tape. Okay? Also too, notice, pull out here, I come to 100. What is that actually? Julie? 100 centimeters. Yeah, good. Good. All these red numbers are actually centimeters. Well, what about the single digits? They're centimeters as well too. Excellent. Yes, but you can see that if you were at the 100 centimeters, you're actually at 1,000 millimeters. And you can count each individual tick, which is 1 millimeter. So we're going to measure this 2x4. It's the exact same way as if you were measuring it with the imperial system. Hook your tape, read to the end. I can read this all the way down to precisely 557 millimeters. 557. And because I can, and it's on my tape, I can find out that's 22 inches. So, nothing changes when we're measuring using the metric system. It's all on our tape, we just read out the values. What if we don't use the metric system to measure things? Well, we have some conversion rates, that we can apply to jump from the metric system measurement to another system, say imperial, okay? For instance, I'm going to put a few up on the board here. And again, these are the most popular ones. There are others, and you can find these online, or some of you may have an app on your phone. Gary's the app guy. He's usually got, and he does have a conversion. So Gary's got the conversion app, but I'm going to put a few values up here on the board that we can use to jump from the metric system to the imperial. 1 meter is equal to 3.28 feet. Okay, all right. 25.4 millimeters is equal to 1 inch. 1 kilometer is equal to 0.621 miles. And lastly here, one for construction, cubic meters. 1 cubic meter is equal to 1.308 cubic feet. So if we have values in either in cubic feet, we can convert over to meters cubed. If we have meters cubed, we can convert there. So these are just some values that you might want to remember, take notes. These won't be on a test, but it's good to remember some common conversion factors. Okay, so we may use those on your assignment sheet later. Wink, wink. All right, everyone got those? Excellent. So let's apply this to construction. Let's apply the metric system to construction. We have a column. Okay, the dimension of the column is 2.440 meters. Column. 2.440 meters. I'm going to write it this way. 457 millimeters wide and 610 millimeters long. So, just like any measurement system, you want to have everything in the same units. Okay, it's not good enough to be in the same system because, again, if you had inches and feet, you can't compare those. All right, so what we want to do, we've got meters and millimeters. So let's make all of this one unit, okay? And let's pick meters. All right, because what we want to do in the end is find out the amount of concrete that goes into this column. So we're going to pick meters. We want cubic meters. Okay, so this is an easy one. That's just 2.44 meters. Okay, this, we have 457 millimeters. Okay, if we're going to go to meters, what do we need to do? Julie, you got it. Divide by 1,000. Just divide this by 1,000. Okay, we have 0.457 meters. Good. Okay, then for 610, Gary, you got it. 0.610 meters. Perfect. Excellent. So now we can just do a simple calculation for the volume. Multiply all three values together, and it comes to volume of concrete is equal to 0.680 cubic meters. So usually if we're doing a takeoff for our concrete, we would tell our foreman it's exactly 0.68 cubic meters. They may round up to 0.75. They may be adding this into a larger takeoff with all the other crews who are pouring whatever it is they're doing. But you can see here, very simple. If we had 8 feet and 18 inches and 24 inches, we've got to do some conversions there as well. This is simply just moving a decimal place. So that's why the metric system is a lot nicer when we're moving from smaller measurements to larger units. This is actually really nice, just dividing or multiplying by however many jumps you've got to make in those prefixes. So, with that being said, we're gonna work on our handout. We're gonna complete the conversions within the metric system. We'll complete the conversions going from metric to imperial and imperial back to metric. Okay, and we're also going to do a measurement exercise with the 2x4s you've got and the values that I've got on the sheet there. I want you to pull and measure precisely to the millimeter. Okay, I want precision here because a millimeter is very tiny and it's going to take practice getting it bang on. I want you to be able to count to the exact millimeter, all right? Very important when we're trying to locate structures out on site. When they're supposed to be where they're supposed to be, let's put them to the mill. Okay? The metric system is an important measurement scale because it's used around the world. It's a simple, standardized system for measuring quantities of length, mass, and volume, and is used throughout the construction industry. Each carpenter must be able to use the metric system with confidence and interchangeably with U.S. customary units. Knowing how to convert values within the metric system to imperial is very important and a critical skill a carpenter must master. So, if there's no other questions, let's get started on our worksheet. Thank you very much.